Mhm. Okay. Hello, everyone, and welcome to the afternoon sessions with Graphic Days. Graphic Days is a cultural project and a visual design festival founded back in 2016, and it's based in Turin, Italy. Since its first edition, Graphic Days has hosted a different guest country in an exhibition named Eyes On, with the name of presenting the best of visual design from a selected country. On occasion of Graphic Days Eyes on the Netherlands, we are presenting a program of digital events dedicated to the Dutch visual communications and the contaminations of the European trends and influences in this sector. The Eyes on the Netherlands project was born in collaboration with Graphic Matters, a design festival from Breda, and the Embassy and the Consulates of the Netherlands in Italy. So today's guest is Edwin Jakobs, a computer scientist, visual artist, and a creative coder from a design studio for interactive media, RNDR. In his work, he creates software tools to transform data from the formless to the visible and tangible. Together with his partners, they develop processes, create structures, design visualizations, code programs, and create interactions. RNDR has developed a coded language system as a part of the exhibition The Palace of Typographic Masonry, curated by Richard Deason and currently on show here at Graphic Days Eyes on the Netherlands. The studio made an experimental software program that can visually translate text into ornaments. So, for those of you who can visit the exhibition in Turin, please make sure to come before it ends on May 30th. And I welcome Edwin Jakobs to studio.
Hello. Hi.
Hello.
Uh, Thank you for the introduction. Um, then I would like to start my presentation now. Yeah. Um, I think the studio has been properly introduced, but I will give my own version of it um, through the eyes of Google Street View, since Street View is one of the interesting things with Street View is that it's a way of seeing the world, um, a way of seeing the world, and not directly through your eyes, but through a system of sensors. So we're actually seeing um, our studio, or the street where our studio is in, uh, through Street View, through data. Um, we're looking at a street in The Hague, and if we zoom in a bit, we see our little studio here with the RNDR texts on the window. In that space, we work with around 4 people to create design uh, that's usually based on data visualization, and preferably the works end up as yeah media installations, or things that live in between data and the physical space. If we look further at this image, we see that Street View also captured one of our works that happened to be on display in the gallery below our studio. And the interesting thing is that the work here is called Replace. It does a similar thing to what Street View does. It removes people from images. So we can have a quick look at what that looks like. Here's a little promo video of that work where you see someone walking that has been removed. And here you see a screen with a person that has been removed from the image. So actually that installation is a piece of software that understands just enough of the world to be able to do something with the world. So it's able to recognize that uh, there's a person in front of that screen, and it's able to remove it. And I think that idea of software that understands enough of the world to be able to do something with it is pretty much in line with the essence of our work. And like the thing that we do with the world, that is a very large set of things that we could possibly do. All right. Yeah, before I wanted to say anything more about the studio, I would like to talk about the tools that we use. One of the most important tools that we use is a tool that we've made ourselves. It's called Open RNDR, and it's the essential tool. Almost every project that we do is based on Open RNDR, and that's also, I think, defining for what the studio is. Everything starts in software. Well, what is Open RNDR then? It's what we call a framework for creative coding. That means that it's a tool for programmers that allows programmers to create visual and interactive media work. So that can be installations, can be visualizations, can be print design. Important thing is that the software that we made, it's on GitHub, so it is free and it's open source. Anyone can use it. Anyone can use it in the way they want. They can also contribute to it. So also, Open RNDR is not fully made by us, but it has contributions by other people. We have a small community of enthusiasts that, well, they use Open RNDR, but they also contribute to it. Yeah, what else? Yeah, what is Open RNDR? It's a framework that is with which you can make software that runs on desktop. So no software that runs in a browser or on a mobile phone. It's currently desktop only, but you can pick whatever taste of desktop you want. So you can run it on Mac OS, Windows, or Linux. One of the important goals of Open RNDR is that, and that goal is specifically for our studio, is that we can use it to sketch and to prototype designs very easily. Um, so in our work, it is the sketching phase is very, very important. So we often start with an idea, and this idea we need to visualize. We need to be able to see uh, how that idea can manifest, and often manifestation of that idea turns into a change of the idea. Often is after you draw something, you get a better grip of that idea. So there's a lot of iterations on ideas. So yeah, you can say that in our studio, the drawing and thinking are equally important. Yeah, what you see here is a, a small set of the drawing tools that are inside Open RNDR. Yeah, they look very primitive, but they can be combined in ways that quickly make things complex. And they are also not all the tools that we have, of course, but I think these are really they cover 90% of what we need in sketching. Yeah, also with Open RNDR, we make tools that can be used like internally, but we also have made tools for clients. Here you see a tool for a pretty complex weaving process. What is important is that when we make sketches and we make prototypes, is that we can take the code that we wrote for those sketches and prototypes. We can easily move that into a production phase. So we often work with a very small team of programmers. It's basically me and my colleague Boyd. We can sketch on things and we can bring those sketches into a production phase. And for production, we can stay in the same tools, and yeah, obviously in the same team. I think that's a very important quality of what Open RNDR does for us. Yeah, here you see a tool that is called Pacture, and we use this tool internally. So that's also why it looks very rough. It's also a tool that is not very easy to use, but it does really interesting things. In this case, it's a tool that places shapes into rectangles, while also taking care of a lot of constraints for where these shapes can be placed. So it's a tool that is um, used to make pretty complex compositions of shapes, and this has been used in visual identities that in which we used these complex compositions. Can also be used to fill in type. Yeah, this is a great example of a data visualization that you can only make when you have data and the tools to visualize that data. So this is one of the this is an outcome in a series of sketches where I started with a map visualization where I wanted to show how far you can travel within a given amount of time. And the beginning point was like very simple. It was like showing circles on a map, but in the end, it turned into something that actually simulates the routes over which you would travel. And yeah, I think this is also important in the process, is that we can sketch with data. um, I think it's very important when you work with data not to fantasize about what the data is, but really work with the data and try to visualize the structure that is sort of inherent or embedded in this data. This is an interesting work where we really used the quality of open RNDR, where we are able to take sketches and move them into production quickly. So this is a video that is made for an online festival. It's part of a campaign where um, users can upload a short 30-second video sequence in which they have to do a small like choreographic movement, and they have to explain what is the thing that they profoundly know. They upload that video, and our software compiles a new video using a lot of things that we actually very quickly sketched out and combined with the video that was uploaded. And this was made possible by creating a small customization of the Open RNDR software that allowed us to run Open RNDR inside a server on a data center. And yeah, what I really like about this is that like when you sketch in code, it has like a certain visual quality that looks very makeshift, very. I think it often looks very fresh. And what I like here is that we can use those visuals that we made in code and use them in production, and we didn't have to hand over the work to another team that would build this server. So it's I think it's great that you can do this with a small team. This is also an open RNDR based work that is not screen based, but instead it drives a very large LED installation in a public space. And I think at this point, the work now runs for I think a good 5 years. And in these 5 years, I don't think we had a single software failure. And well, that's not necessarily a quality of open RNDR or a specific quality. But again, given that this is made by a small team, where that team designed the light animations in code. So yeah, the code and the light design are almost the same thing. This is done in sort of in our typical iterative sketch way, and that code was brought into production again by a small team. Um, so yeah, I think the tools really work for us. Yeah, to reiterate, what we design is, well, a large part of what we design, it starts in code. So that really means that what we produce, looks like this. Writing code in an editor, and the output is something that you can see. One of the commonly used strategies, especially in the sketching phase, is that we write small programs, like self-contained programs, uh, and when we recognize that we want to change something in this code enough for the outcome to be significantly different, what we do is we copy the program, and we paste it, and we up the number. So you see here a bunch of small programs for which the numbering starts at 1, go to 2 and 3, and a lot of our projects in the sketching phases look like this large collection of small sketches. Uh, the nice thing is that all those sketches, all those small variations of an idea, they can exist side by side. So you can always go back and compare things. To make this even better, there's tooling inside OpenRNDR that allows you to um, basically write anything that's on the screen to a video file, and that usually results in folders with a lot of small videos, and those videos we use them to archive it and to communicate, like, internally. It's we use Slack, so it's very easy to upload your video files to the Slack and have other people look at it. um, I also think archiving in video is just a bit easier than archiving the code or sharing the code. Although I do think there's something nice about being able to share interactive prototypes. But the problem with that is that for some reason code doesn't really allow itself to archive very well, mostly because there are so many factors that influence your code. So your code often depends on other people's work. That other people's work uh, may change or for some reason disappear, and then your own work may stop working. So um, there's not much you can do about that. But we sort of try to use video files to circumvent that problem just a bit. All right. Now that I made or sketched out an idea of how we work in our studio, I would like to spend some time talking about some of the theory that we use in our design. A lot of what we do, I think, in some way boils down to um, language. As I said in the beginning, we would like to make software that understands the world just enough. And I think a large part of that is related to understanding human language, and that in itself is a entirely complex field. But I'm going to show you some things, um, some of our thoughts on this and some of our experiments that are based on those thoughts. So a long time ago, I think a good 10 years, um, we made this installation here, which is called the poster wall for the 21st century. The idea behind this installation is that we try to answer the question, what happens when you remove the graphic designer from the process of designing posters? And what happens when you replace that graphic designer with a computer program that generates these posters? Um, this work basically is an attempt at replacing that graphic designer and generating posters. Um, these posters are generated from news, from blog posts. Basically, anything that is written text can be turned into a poster by this software. Um, I think in the end, it doesn't. Well, it changes the process of making a poster. Of course, like you change the amount of time it takes to create a poster from, say, several weeks to a second. Um, and I think the biggest change is what is then the role of the poster, or what are things that you can make posters about? Because before you would spend like several weeks to create a poster for maybe like a festival or an event, but now we have a machine that can create posters uh, in a second, and maybe we should think about what we create posters then for, because in theory you could make posters about what is in discount at the bakery around the corner. So let's look a bit at the process of generating a poster with this software. So it scans news feeds, and once in a while it picks up an article. When it has such an article, it takes the title, it takes a text, and if there are images, it takes an image. Um, so here we have an article about an earthquake. So what the software does, it takes this image and it tries to, it will use this as the background for a poster. So it applies a visual treatment to it, which is sort of like this dot effect. Then it takes a typographic style and applies that to the text, and then combines the typographically treated text with the image. And then this is the poster. Then in the system we have a number of visual styles. There's a number of typographic styles, and when you mix those together, you can make hundreds of or thousands or endless amounts of posters. And some of the designs, they will actually make sense, but they will only make sense because of pure chance, because nothing in this poster generator understands what well, first of all, it doesn't understand really what a poster is, uh, but it also doesn't understand what it's making posters for. I mean, it's just taking a text, taking a random typographic treatment, taking a random visual treatment, and it combines those two. And I think that now we should be able to understand a bit more what such a text is about, and I think we should also be able to generate posters that are more consistent with its content. A bit of an intermezzo. Currently, we are also working for an exhibition, and that exhibition is called Perpetual Beta, which I think is a great name for a show that is about showing works that are not finished. They are in progress, and they will likely, given enough time, forever be in progress. Our contribution to this exhibition is a machine learning algorithm that replaces our entire studio, and that sounds like sounds like a really grand scheme, but we are also absolutely positive that this will not work at all. And the biggest gap that you have in machine learning and simulating people it's a language problem. There's this really nice theory. Actually, there are several. So there's, for example, Wittgenstein, who says language, the meaning of language is its use. So that means that basically you will not be able to find for any text, say a logical system that explains what that text means. And there's another great theory in artificial intelligence mostly, that says that intelligence needs a body, and it needs a body to be able to do things in the world. Together with the idea that language is, or human language is a product of the human body, you get this nice thing where if you were to make a system that would understand human language, it would have to be a system that is housed not inside a box, but inside a human body. And well, that is the primary reason for this experiment of making a machine learning algorithm that replaces our studio to fail. What you see here is a small simulation of our studio, and this simulation is based on looking at all our chat logs that we of all our chat logs of our Slack that we use in our studio. So it is able to see that there are people communicating. They may use words that are related to what we do in our work, but I don't find this human at all. And I think trying to simulate a studio just based on chat logs is maybe too grand of an idea. In another experiment with language, I asked myself, is the meaning of a text, is that meaning a color? Which is a pretty strange question to ask at first. But let's try to give that an answer. So what you see here is a list of the 2,000 most common words in English. And what I did for those 2,000 words is, for each of those words, I used image search to find images that match that word. So you literally go to Google image search, you type in, for example, family, you would download the images, and then you analyze the color of those images. And the most frequently used color is the color that you assign to that word. So yeah, using that technique, I made this what is it, a color dictionary. So for every word, we have a color, and it's a bit hard to see, but yeah, you can see for some things. There's, for example, the word red, and it's obviously colored red. There are also a lot of words there that are more abstract, and you can already see for the images that you get from the image search that there's a bit of a mismatch with what you had in mind for this word and what image search has in mind for this word. So there's already a bit of a gap problem. Then using this technique, I took a text, and for each word in this text, I do this. I go through the same process. I look up images for that word. I find the most frequent color, and I draw a colored bar below that word. So that gives you this. Now, if the meaning of text were color, then if we would remove the text, we would still be able to understand we would still understand the message that's written here. So we do this. I think the hypothesis is not true, but still, it's an interesting experiment to look at like the meaning of a text through an image search. From this image search, you get images that match a word, and you try to get some data for it that still has like some sort of physical component to it. Another way of looking at the meaning of text is and this is a really complicated one. It's to create first you define a language, and you say language is a whole lot of words. Then you're going to create a space where every word is represented by a point, and this space is very high dimensional. It's like, say, 500 dimensions. Now we have to organize those points in this space such that we encode information just in the positions of the points. This is a very abstract way of describing a machine learning process, but you can imagine that you make a machine and you have a lot of texts, and you're going to let this machine read this text, say 5 words at a time. From 4 of the words that you feed it, this machine will try to predict what the 5th word is. So you feed it 5 words, 1 of the words you blank out, you let the machine guess what is the 5th word. If it guessed it wrong, that means, it tries to guess the 5th word from where the words are placed in this space, right? So it has the points have sort of meaning to the system. When it guesses the word wrong, that means that it has to move these points around in the space, just like a tiny amount. If you do this often enough, then at some point you'll have a space that can be used to predict these words correctly. And then there's an interesting thing to the space, and that is that it actually contains a lot of information about the meaning of text. But the meaning of the text is so the meaning of a word is in this space relative to the meaning of the other words. So it's all it's all relative, and all the information inside the space is only say valid inside the space. Okay, once we have the space and we know that each point represents a word, if you would take the word typography, for example, then the points that we find nearest to the point that we take, they represent words that are related to typography. So it has learned sort of word relevance. So that's already an interesting thing. If you have any text, think about a poster generator. If it sees a word, it can try to do something with the words around it to understand what this one word is about. Then there's another really interesting aspect of such spaces, and that is that it has the space encodes word analogies. So, for example, if you take 2 points in this space, say the point that represents the word Italy, and the word that represents the point that represents the word Rome. We have 2 points. You can imagine that there's a line between those 2 points. This line has a direction. If we then remove the point for Italy, or we remove this line from the word Italy to France, we would see that on the other end of the line, the nearest point that we will find is Paris. So it has sort of it has encoded a country to capital kind of relation, and it works pretty well. So it's for South Korea, it finds Seoul. For Netherlands, it finds Amsterdam. For Belgium, Brussels. Also works pretty well for things related to gender. We see like Italy to pizza is Japan to sushi, Korea to kimchi, Netherlands to pancakes, America to McDonald's. So that obviously encodes a nation's favorite food. It works pretty well with spatial spatial relations. But the thing, and that was related to my previous question about like seeing the color of a word, that actually seems to work really bad. So if we take the relation tree to green, it can find that the sky is blue. But for even simple things like the color of a panther or a zebra, it completely fails. So I would say that this is like a representation of the world that it is learned from texts, and it also really strongly depends on which text you read. But there will always be sort of a mismatch in how you would answer these kind of questions. Like if you would ask a person what is the color of a panther, I think there's more than just symbolic information in someone's head to to answer that question. Here we see an experiment in visualizing that very high dimensional point space into something that we can actually see. So this flattens this 500 dimensional space to just 2 dimensions. And you have to imagine that every point represents a word. And I find this a very intriguing image because it basically tries to model what a language is in a way that we can see it in just 2 dimensions. And this idea I found so interesting that we made an installation around that image. And in this installation, we work with the idea of a cube that when no one is around, it only thinks about language in a way that is sort of native to this machine that is inside this cube. And as soon as someone is in the space and walks towards one of the sides, it will transform these points into something that is more like human language. So here we see 3 of the sides at the same time, and someone is walking towards those sides, and each of the sides has like different ways of dealing with language. So on one of the sides, we see a one word made out of small dots. So that's the idea that like every word in this model is actually defined relative to all the other words in the model. Then there's on the right, we missed it. On the right, there's also an interesting idea. If words are points in space, that means there are also there's space between those points, and it's trying to answer what is in between those points. So it's making up new words based on this point space. All right. That work was shown in Seoul, in Korea, and I think that was in 2017. And that was also the year that I met Richard Nissen. We had very interesting talks about actually about this same topic, language, computers, design, and he invited us this year to contribute to the show that is now on for Graphic Days. And the idea was to contribute on a publication for a publication that is about kente weaving. And kente weaving or kente cloth is a technique that origins from Ghana, and it's a very interesting way of weaving in which there's a very hard to define system to make these designs, mostly because most of these designs are very specific to its creator, and that creator he follows, or they follow traditions that are not easy to capture, I would say. So it's an interesting problem where there is information, and that information doesn't only live in rules that you can write down, but it also lives in the materials that you use, where on earth you are, etc. There's also one really interesting thing that is also related to communication and language, is that creators of such designs, they encode bits of information in symbols in these designs. Such symbols can represent the status of the creator or the status of the person that wears that design. And that idea has actually led me to to create designs that are sort of similar to the kente weaving, but they're our own system. But these designs, they include the entire publication that is written in text in a pattern. So here we see some of those patterns. And there's actually a pretty elaborate system behind all of this. I'm going to try to explain this. First of all, imagine a very short piece of text that just says "Hello world," and we have a very small set. Actually, we have black rectangles and white rectangles that we can stack on top of each other, and we can say that each of those small stacks, they can represent a letter. So we are sort of making an alphabet here. Then what I want to do is to create an alphabet that if I want to express this hello world with this alphabet here, I want to use as few rectangles as possible. So that's actually, this is a little compression trick. And there's a very, yeah, we can make this, we can assign this alphabet like this. So first we're going to count all the letters in our message. So L appears 3 times, O 2 times, H 1. Now the idea is that if you assign your most frequent letters to the entry in your alphabet that has the least amount of rectangles, then in the end that will lead to the shortest encoding, right? If we take a different message, for example, a so-called coding system, we see that well, our alphabet is longer, and also the assignment is completely different. So we have this very not so natural idea that we have an alphabet that depends on the message. But in this case, it is really interesting because when for every message we have a different alphabet. Then there's a second step. So imagine that we have some stacks of black and white rectangles, and we want to place them in a design, and this design is a rectangle here. We have to we have to organize the spaces that we can place those rectangles there. And this is done by splitting this space, as it is called. So the first thing we do is I split horizontally, and that means that in this top bar now, one of those squares would fit, but it's still that space is still too big. So you split it another time, then you place the square in there, you split it another time, and then this one goes in there, this one goes in there. Now imagine we have something completely differently shaped. This doesn't fit in the free space that we have, or like one of the free spaces, the one on top is too small, the one in the bottom is too large. So we split this again like this and like that, and we place it here. So this is the second method that we use to create these compositions. So first we make alphabets that depend on the text, then these characters of this alphabet are placed on a canvas like this. So there's actually a tool that does this for us. So here you see the text in the publication being typed out, and you see it being placed as a composition on the right. So what happens when this is typed out? Our alphabet is constantly changing, and because the alphabet is constantly changing, the rectangles that we're finally going to place in our composition also change a lot. So it becomes very hard to predict what this message will be will look like. And I think there is some there's a link to be found with the idea that it is hard to systematize the the encodings that are used in canter weaving. Yeah, here we see some prints. So you see that on top of these visual encodings, there are colors. Um, these are placed there by hand, and they sort of reflect one of the aspects of the canter weaving, where there's a base layer that is often made by weaving, and then often or sometimes by hand there is some extra layer put on top of it. So I think this kind of reflects that way of making those designs. So this is put together in the show. So you see on the front you see the publication. In the back you see the publication, but not folded. And on the left there's the video that shows this composition process, and the entirety is in the show here. All right, that's it for me.
Okay. Thank you so much, Edwin. And it was also great seeing the pictures of the exhibition here in Turin. So for everyone who can manage coming to Turin, Edwin will be here, by the way, this weekend. So he's traveling tomorrow. And
Yeah.
he will also hold a workshop together with Print Club Torino on code and printing. So
Hmm.
there are still places left. So if you want to join, you are invited to. And so this will be the last weekend of the exhibition, and we will see you here or during the online event tomorrow with what design can do. Meet you soon at Graphic Days, and thank you so much, Edwin, again for your presentation.
Yeah, my pleasure. Are there any questions maybe from audience or?
Not from the audience, no.
Okay. Do you have any questions?
Well, I had a question, but I think it's not really the greatest question. But do you have any clients that actually don't know that you use computer-generated art in your projects?
Yeah, that's a good question, but I think very often they know exactly what they sign up for, right? So
Yes, that's what I thought, because
yeah,
what you do is not that common. So probably people who work with you, they already know about the type of
yeah.
where your projects come from. But at the same time, when you especially talked about the poster exhibition
Hmm.
that you made a few years ago, I guess 10 years ago, right?
Hmm.
So you wanted to make something where graphic designer like wasn't present as a figure. So it was quite curious to know if the computer generated design will be the future of design, kind of. But I guess it's already something you are working with. So
Yeah, for me it's the present, um, but this like the process that we work in with the clients, it's always super transparent. It would really be impossible to, maybe it's a fun experiment to work with a client once and not tell anything about that it's made with code, and then come up with these giant stacks of designs, and who knows.
yeah, it's like test of creativity, and then you send them like thousands of proposals, and you tell that you made them in 15 minutes or so.
Yeah.
Okay. Well, I guess that's it. Then we meet tomorrow, and yeah, everyone have a good evening.
Yes, thank you. You too. Bye bye.